Hello class 10th. In the last lecture we have discussed about the movement of couple. In this lecture we will discuss about the equilibrium of bodies. So first point, what is equilibrium? For that, suppose it's a box lying on my hand. So can you think how many forces are acting on this body? You will say currently is nothing seen. But actually the weight of this box acting downward, and due to the normal reaction which is acting in upward direction, it is staying on my hand. Elsewhere, suppose the weight is more than the normal reaction, then the box will go down. And second option, which is not possible, suppose the normal reaction is more than the weight, so body would have go up. But what is the actual? The weight of the body and the normal reaction both are equal. That is why it is lying on my hand. Suppose this is any platform, or you can say the surface of the earth, and this is the box which is lying on this surface. At this time, the weight of the body will be acting downward. Say the weight, you can say, or you can say if suppose the mass of the body is m, so mg, or you can also say just a force which is acting downward. Due to this force, still the body is on the surface. This is because another force, the normal reaction, is acting in upward direction. As the weight is equal to the normal reaction, means W is equal to R, so the body is in equilibrium. So let's talk about the definition of the equilibrium. So the definition for the equilibrium is the number of forces acting on the body 2. If a body is being acted upon by minimum 2 force, means it may be more than 2 force. If the body is being acted upon by at least 2 force, but the body still is in rest or in a state of motion, then that body is said to be in equilibrium. But the equilibrium is also of two kinds. First one, the static equilibrium, and the second one is dynamic equilibrium. This case says the box was in rest. After being applied by the two forces, the box was still in rest. So this type of equilibrium is called static equilibrium. Means after being applicable of the number of forces, the body doesn't change its state. So the body is in static equilibrium. And the dynamic equilibrium, suppose this box is moving in this direction with some velocity. I'm applying some force in this direction, and the air gives the force in the opposite direction, and there is no change in the motion of the box. So there was no change in the motion of the box. Still it was being applicable by the two forces. So this type of equilibrium will be called dynamic equilibrium. In short, this one, suppose the force F1 and F2. These two forces are being applied and the body is in rest. So this is static equilibrium. And the second one, suppose this one, two forces are acting and the body has no change in its motion. So this is called dynamic equilibrium. Little more about this static equilibrium. Suppose a car which is in rest, as you can see, velocity is 0. It is at rest, is standing here. Somebody is pushing in this direction with the force F1, and the other person is pushing the same car with the force F2 in this direction. So if I'm asking in which direction the car will move, what you will answer? Think about it. In actually, you can't answer. You will ask which force is more. Suppose the F1 force is equal to F2, so there will not be any change. This is exactly called the static equilibrium. Means after this, still the velocity is 0. And now dynamic equilibrium. Suppose this car is moving with velocity 5 meter per second in this direction, and these two person, this one is applying the force F1 in this direction opposite to the car, and this one is applying the force F2 in this direction. And suppose the F1 force is equal to F2. So what you will say? There will be no change in the velocity of the car, means still the velocity will be 5 meter per second. So this case is called dynamic equilibrium. So there will be two conditions for the equilibrium. First, for the static equilibrium, the number of forces acting on the body, still the body is in rest or in a state of motion. So that, or the number of forces acting on the body is resultant is zero. The total force, whatever the acting on the body, resultant becomes zero. But the body was moving in straight line, means the motion was translatory motion. What about the rotatory motion? For example, if this scale is lying on my finger, so if suppose I am just displacing the finger, so this stick will go down. Is this a type of motion? What is? Yes, this is rotatory motion. So what about this? In this case, you will say the moment of force in this direction, if it is going down in this direction, and the moment of force of in this direction must be equal. Then the body will be in equilibrium, like this. The moment of force of in this direction and the moment of force in this direction, both are cancelling each other. That is why it is on my finger. Suppose in this way, suppose, so the stick is going down, means this direction has more moment of force than this one. If for this one the equilibrium means the clockwise, for this I think this is for you, it is anti-clockwise. The anti-clockwise movement should be equal to the clockwise movement. Do you know we have arrived to our new topic, that is called principle of moments, that states, what is the principle of movement? That states that if a body is in equilibrium like this, so the anti-clockwise movement is equal to the clockwise movement. This is the principle of movement, or you can also say the algebraic sum of the moments about any fixed point. This is the fixed point. The algebraic sum of all the moments of the body about the fixed point should be 0. Have you seen the physical balance? In that also, the grocers put some weight in one pan and goods on the other pan. When the stick comes straight, you will say the weight in this pan is exactly equal to the other pan. This is what? The equilibrium. For example, suppose a rod is balanced at this point at which it is balanced, sometimes it is called fulcrum. What? Fulcrum. And if this scale or this rod is balanced, it means the moment of force for all the particles, moment of force, I know number of particles will be there, say they are having m mass or m1 m2 m3 mass, whatever. So the moment of force by all these particles which is acting in this direction, and the moment of force for all these particles lying on the other side will be in this direction. Say this is F1 and this one is F2. If it is in a straight line, means it is in equilibrium, you can also say at this case F1 will be equal to F2. Taking one example like seesaw, one student is sitting on this side and the other one is sitting on this side, and this seesaw is balanced, means the moment of force in this direction, say F1, and the distance, all the distances must be measured from the fulcrum. Say this distance is R1, okay, and for him, say the weight of this person is F2, you can say weight or force, whatever you can say, and the distance from this side is R2. If it is balanced, so what says the principle of movement? Which is, if a body is in equilibrium, then sum of all the clockwise movement will be equal to the sum of all anti-clockwise movements. Or in short, we can say all clockwise movement is equal to all anti-clockwise movements. So in this case, taking this point as an axis of rotation, this force or this weight is turning this scale in this direction. This scale is being turned by this force in this direction. So this force is turning in anti-clockwise direction. So these anti-clockwise movement, see here all the anti-clockwise movement. So write it here. What is the equation? The force into perpendicular distance, F1 into R1 should be equal to what? Clockwise. Let's see. This one is turning the scale. This force is turning the scale in this direction. Means this one is going in the clockwise direction. So you will say F2 into R2. So this is the according to the principle of moment, the clockwise and equal to the anti-clockwise moment. But what if one more person is sitting and still the scale is balanced? See one more case. Suppose one more person is sitting with the force F3 and still the scale is in equilibrium. You have to apply same what? In which direction it will turn? In the same direction of F1, means in the anti-clockwise direction it will apply. So let the distance from here to here, it is R3. So now what will be this? The total clockwise movement, this one, the clockwise movement, that is F2 into R2, which is here already. And this one, F1 and F3, both are rotating this in anti-clockwise but still is in balance. So the anti-clockwise movement, that was F1 into R1 already here, plus what is next? F3 into R3. Take one more case. Suppose this scale is still, or any rod, it is balanced with the number of forces F1, F2, F3, F4. So you can say F1 and F2, they are in anti-clockwise direction, while F3 and F4, these two are in clockwise direction about this axis of rotation. Correspondingly, the distances are R1, R2, R3, R4. So what will be the equation? That clockwise movement are equal to anti-clockwise movement. Let's write that. So here you can see anti-clockwise movement, F1 into R1 plus F2 into R2. And the clockwise movements are F3 into R3 plus F4 into R4. In these cases, the body was balanced exactly at the middle. But what if the body is balanced except the middle? Like, suppose this is balanced from the middle, so clockwise movement and anti-clockwise movements are equal. But suppose I'm displacing this fulcrum in this direction, so the scale will go down. To stop that, I'm putting some force here. See, extra force, this one. This force is balancing the whole scale. How? If one force is here, so who is the next one? The answer is the one which I'm applying the force in this direction. The second one is the weight of the scale. So point this, whenever the body is not balanced at exactly middle, at that time the weight of body will act. For example, suppose another rod, instead of being balanced at the center, I am balancing it here, somewhere here. Now this point is our fulcrum. So I said the weight will act. So whenever the scale is balanced except from the center, then straight right there, what you have to write? The weight of the scale. Without thinking anything, whenever the scale is balanced except the center, except the middle of the scale, put sudden the weight of the scale. And suppose it is being balanced by this force, say F. At this time, still if this scale is balanced, so let the distance from here is R1 and from here this is R2. This is what? The weight of the scale. So F into R1 should be equal to what? W into R2. In some questions, you will be asked to calculate the weight of the scale. So from here, W is equal to F into R1 upon R2. By this, you can calculate the weight of the scale. Now see the question of practice problem 6 of your book. Question number 2. A uniform meter scale is balanced at 20 centimeter mark. A uniform meter scale means the length of the scale is 1 meter. So suppose this is the scale of 100 centimeter. I have marked the one end at 0 centimeter and the other end at 100 centimeter. And written here, this scale is balanced at 20 centimeter mark. So somewhere here it will be. So let this is 20 centimeter and it is balanced. So wherever it is balanced, we have to show the fulcrum and mark it as 20 centimeter. So at 20 centimeter, it is balanced. And I said, whenever except the center, anywhere fulcrum is, then what will act at center? The weight of the scale. This is the center. If the fulcrum would have here, so no weight will act. But now the fulcrum is here. So at the center, the weight of the scale will act. So if the weight is acting in this direction, so someone will be there to balance it. In which direction about you, according to you? In this direction you will apply some extra force, or in this direction you will apply some extra force to balance it? First question this. So read the question. When a weight of 100 gram force is suspended, this is extra weight I'm going to apply, I'm going to put somewhere here. The question is, where must the weight be suspended? So I'm asking you where you will suspend this 100 gram force to balance it, in this side or at this side? Yes, at this side. And written here, one end. End means at the extreme. So I'm putting at this point the 100 gram force, and that is why it is balanced, because of this and this, these two forces. Okay, now mention the distances. This is 0, 20, so this will be 20 centimeter, and this is the center, this is the middle part of the scale, so this will be, I think, 50 centimeter. So the distance become 30 centimeters. So first part of the question was, where must be the weight suspended? The answer is at 0 centimeter mark. And the second question is, calculate the weight of the scale. So writing the rules, principle of movement, I'm writing in short. According to principle of movements, clockwise movement is equal to anti-clockwise movement. So see, in the clockwise, this one is turning. So the weight, the force and the perpendicular distance, the force and the perpendicular distance, same way for this one which is turning in anti-clockwise direction, 100 into 20. On calculating, W becomes, on calculating it comes to 66.66. The unit of this force was in gram force, so the unit of this weight will also be gram force. Start. So we have seen the definition of dynamic and static equilibrium and the principle of movement also, and we have solved one question. I would say please solve all the questions and inform me if you are facing problem. See you soon. Thank you.